Alrighty, our very last review topic for the year. And our last math topic for the year. So this is about solving quadratics using something called the zero product property. So what this says is if you have a number A and another number B, and they're being multiplied together, and we know they equal 0, then A is equal to 0, or B is equal to 0, or they're both 0. A equals 0 and B equals 0. So that's option 1, 2, and 3. So this is how we're going to use it to solve quadratics. So here we're given a quadratic in factored form, and we know that the quadratic equals 0. And we're asked to find for what values of x makes this true. So here we actually have A times B equals 0. So what we're going to do is we're going to set A 2x minus 1 equal to 0 to figure out what value of x makes this equal to 0. So add 1 to both sides, divide by 2, we get x equals 1/2. And we'll repeat for b. X plus 4 equals 0, because remember, it could be a is equal to 0 or b is equal to 0, or both. Subtract 4. So we get two values of x. So our solution is x is equal to 1/2 or -4. They're both of them are part of the answer. So let's repeat. Again, we have a quadratic in factored form. So we have a times b is equal to 0. We're going to see, okay, what if a is equal to 0? Well, then x is equal to 5. What if b is equal to 0? Then we have to do some more undoing. And we know that x is equal to -2/5. So x is equal to 5 or -2/5. You could also write this as x is equal to 5, comma, -2/5. Both are correct forms of writing your answer. Let's do another one. Here we do have a times b. It just looks a little bit different. A is just 3x. So we have what if 3x is equal to 0, or what if 5x minus 1 is equal to 0. Here x is equal to 0, because you're dividing by 3. Here we have 5x is equal to 1, x is equal to 1/5. So again, our solutions is 0 and 1/5. In number 4, this looks a little bit different because we're not given it in factored form. So what we have to do is factor it ourselves. So we're going to move this into factored form. We're finding the greatest common factor in both of them. Well, I notice both have an x, so I'm going to pull out an x here, and we'll get 3x plus 18, because if we were to expand, we'd get 3x squared plus 18x, still equal to 0, and now we have it in a times b form. So we have x equals 0, or 3x plus 18 equals 0. Do our undoing. So we get x is equal to 0 or -6. Another phrasing could be for what values of x does -20x squared minus 24x equals 0. So it's just writing it in a sentence as opposed to an equation. So we can take this orange part here and write it in a mathematical sentence by substituting the word equal for the equal sign. And we're back to just like the question 4. We have to factor it and then set each part equal to 0. So we can pull out an x, and I also notice 2, a -2 actually can come out of both. So then we have 10x plus 12 here. So -2x equals 0, x is equal to 0. And then we got to do the other side. And this can be simplified to -6/5 by dividing by 2. So our final solutions are 0 and -6/5. Now let's take it up a level. So in Algebra 2, you might be asked a question like this. If f of x is equal to x squared minus 10x plus 21, what are the solutions to f of x? So what does I'm going to make a connection to the graph. So if this is telling us that this is a graph, f of x is a function of x squared minus 10x plus 21. And it's going to look something like this. And instead of the word solutions, there are other names that you could be thinking of. You could be thinking of x-intercepts or roots. And these are all synonyms. So x-intercepts, roots, and solutions. These are when y is equal to 0. So there are these points on the graph. The points I just made darker, I'm highlighting in orange. They're what we call solutions or x-intercepts or roots. And this is actually exactly what we've been doing in the previous question. We've been finding solutions or x-intercepts or roots. So what we're going to do is we're going to take this orange function, we're going to set it equal to 0 because we want to find when y is equal to 0. And now we see a question just like we did in number 4 and 5 where we need to factor. So I'm going to go off to the side here, use our area model. We have x squared, positive 21. We know that these two orange spaces have to add up to negative 10x. We know this is going to be x and x. And we have to think of, okay, what are two numbers that multiply to 21? Let's try 7 and 3. So plus 7 plus 3, so that would be 7x, 3x. Well, we have 7x plus 3x. Well, that equals positive 10x. So what if we made these negative? Both of them negative. Oh, yeah, that works. Okay. So then we know that our factors now are x minus 7 and x minus 3. So now we're taking this back up to the original question was, what are the solutions? So since we want to find the solutions, we want to know what if a is equal to 0 or what if b is equal to 0. Set each part equal to 0. Undo, and we get x equals 7 and x equals 3. So this blue dot here is where x would equal 3, and this green dot here is where x would equal 7. So that's a connection to what the graph would look like. That's why we call them solutions or x-intercepts or roots. So those solutions to f of x are x equals 7 and x equals 3. All right, ask me lots of questions during class, office hours, you name it, I'm here for you. I'll see you in a little bit.